Okay, I've been trying to chase this down a little bit. So, some amps. This is your common older 8K. Most of them run the same board, especially S&I. So, anyway, we have, let's take a peek into here, 200 volt caps. These are in series with each other, or they can be, it just depends on your test points out here. These are all your rail connections, these bigger pads. Where my meter is connected, one is the positive rail, one is negative rail. Center point is a 0 point or ground. In a half bridge, this will be speaker ground. And over here is also positive and negative rail. Positive being over there and negative being right there. So, one set of caps is for negative rail, one set of caps is for positive rail. When they're on the board between rail to rail, these are in series. So, your voltage rating on these becomes additive. You lose. You don't gain microfarad. You lose it. you don't double your microfarad in series. So anyway, I keep these covered because I flip it over and keep them getting scratched and white shit all over everything. So anyway, I've had this on and the resistors are doing, these are bleed down resistors, bleeding the caps off like they're supposed to do when the amp's powered off. Now, 12 volts. And yes, for you big gurus out there, yes, when you add the amp section, the rails will sag some when you put FETs in line. Yes. But you're still within a few percent of your rating of these caps. And the FETs, their tolerances are a little different. So anyway, this is 12 volts, and I'm going to turn it on in a second. Hit the remote and drop below 50 volts, so we go to 4. Now, here we go. Remote switch on. Here we go. This is rail voltage, rail to rail, not rail to common ground, rail to rail. And once we give it a few seconds, this is only a 10 amp supply, so it's got to settle down a little bit, about 2 3/4 amp, because there's no load on it. The only load on it is the resistors. So we're at about 290-ish, just under 300 volts at 12 volts battery voltage. Yeah, there's nothing else connected. So anyway, so we've settled there a little bit. Now, I don't run the power supply up and down when it's on. So I'm going to remove remote. It'll start falling off. The bleed resistors are going to do their job. Now, we're going to go to 14.8. Alright, 14.8. Hopefully it'll settle in there. Now let's hit it again. Turn it on. Still going. We were at 290 volts at 12. 14.8. And remember, these 200 volt caps become additive, so they're 400 volt tolerance. $200 volt per rail, so if you're reading between rail and ground over here, that would be half of the voltage here. And just to prove that point, we'll take this and go to ground. So now we're going to get half of what we just read. 188 volts. Now we'll go back to rail, which is double. There you go. Now, it's settled in a little bit, 14.8. Now, let's jump into the lithium world now. Turn it off. Now, let's see where everybody likes to charge. What? 15... we'll go 15.5. When I ran these 8Ks, that's where between here and 15 was where I actually seen the most power. It's where this was mostly happy. So 15.5, we only went up from 14.8 to 15.5. That's 0.7 of a volt, not even a whole volt. Now let's see where it goes. Powering back up. Climbing. Okay, now we just went past where we were. Still climbing. $15.5. Woo! We're in 7. It's going to be closer than that. It's going to be on up there. Now we're within 6 volts of maximum rating of those caps. 200 volt caps. Let's go back to there. 2 7/10 of a volt, if this meter's reading correct. 6/10. 2 6/10 volts within top voltage of that. Yep, 5 volts. Now we're at 50. We're at 15.5. Some people like to go higher than that. This is a regular 8K. Now, all right. Turn it off. Now let's go up here to where some of these other people like to live. Like 15.8, 15.9. Let's go to 16. There. 16 volts. 16 volts. Coming down. Now, alright, here we go. We'll live dangerously here. And we'll hit it. Coming on, powering up. And I already know it's going to surpass rail limitations. So let's see where she goes at 16 volts. Well, there's the top. Now I'm kind of backing off a little bit because yep. So we are above the rated capacity of those caps. So, turning it off. Now they shut off at 16.2, supposed to be anyway. But I just thought I would show everybody that this is just a 8K. There are a couple of amps out here. I know the Crescendo amp, the 12K, I do believe, goes way above that. So, know for a fact. In fact, I have 2 here. The last 2 that I will take in ever. We're not even at shutdown voltage, but some people like to live up there. Lithium is the killer of amps when you don't run it right. Bleed down resistors. So when I say run it right, run it within reason. I mean, and when you wire your amps at this high voltage, when you run your batteries, your lithium batteries at 16 volts on CMAX 16.8 is the top. Some people like to go way up into the 16s if their amps don't shut off. But why would you want to go past that? That's, why? and then complain, whine, and cry, well, this brand won't do it, they blow up and they do this. When you wire sub-ohm, you're already demanding way, way more current out of this than what it was designed to do at that high voltage. There gets to be some buffer, some padding when you're at a regular 12 volt battery, AGM, whatever, 12-8 system. You get buffers. Number one, your FETs are not at their maximum voltage. So in this amp here, this just happens to be one of the outputs, the 24N40. And well, I don't have my computer on, so let's turn the computer on. And turn the power supply off. Turn the soldering iron off. Hang on a second. We'll be back in a few seconds. Okay. Well, got the computer up, and that FET. Oh my goodness! One can ship immediately. Hope everybody's got their stock in these things. So anyway, now let's go to the data sheet. I thought I had the data sheet saved. So, on semiconductor, scroll down here. 400 volt FET, 23 amps. Now, 23 amps, that is at 50% duty cycle. So, they don't give you no plus or minus over here on their main voltage. This is the drain to source voltage. 400 volts, not plus or minus 30. This is gate to sort voltage. So, yeah. Why would you want to surpass that? That is the absolute limits of that MOSFET. So, yeah, like I said, lithium is the killer of amplifiers because nobody knows these part numbers and what their ratings are. You guys don't know that. All you guys see out there is, just a logo on the outside of an amplifier. That's all you see. You don't know the internal workings of an amp, how it works. But suddenly everybody wants to live in the old school world of the 12 volt system. Yes, these could at 12 volts survive at quarter ohm. I've seen them survive at less than that. But at peak voltage, you can't tax these things for their maximum current. They will pop every time. Guaranteed. Guaranteed. Just a little FYI on your Labor Day weekend, Monday. This is Monday. Yes, I am working on Monday, the Labor Day day. But I thought I would take a few minutes out of my day to help some people understand that, living at 16 volts and at quarter ohm or half ohm will even hurt these at that high voltage. So stay away from that ultra high voltage. Go ahead and use the lithium for its discharge, lightweight and discharge capabilities, but let's not take them to the max. Don't take these to the max. It's dangerous up there. If you're going to do it, hope you got the wallet to fix it. So, happy Labor Day. Catch me later.